In this short presentation, I will be discussing and quickly looking at a separation schema. But first, I recommend that you search Google and download a free copy of the periodic table where the ion charge values are shown as having 3 decimal points or more. You will find that you will need this table if you want your calculations to be more accurate. This is what your periodic table should look like. It will include the element symbol, the element name, atomic number, and the atomic mass in grams. As you will see going forward, the atomic mass is the most important value. In addition to, locate and download a free copy of the solubility of common compounds in water table. The solubility chart will also be an asset that you may use often. There is also one more for now that needs to be found and downloaded. It is a copy of the relative strengths of the Bronsted-Lowry acids and bases. Now, if you're not able to find and download free copies of these tables, feel free to contact me and I will send you a PDF copy containing these tables and more. They are a must-have going forward. In any schema, there is some logical approach to a process that comes to an ending. An analyte, being the element of interest, its separation schema is no different. The approach has 4 elements to it. The first is group separation. There are 7 groups, each containing elements that can be separated. The second is the individual elements in each group, which can further be separated, that is to say, isolated from each other. The third element is the final tests that are involved to identify each element within its respective group. And the fourth is the design of the method to be used, which would include reaction equations, flowcharts, and explanations, including any enhancements. The groups and associated elements are as follows. Group 1, the silver group. Its elements include lead, silver, and mercury. These elements are precipitated or will precipitate as lead chloride, silver chloride, and mercury chloride. And as such, this group is sometimes referred to as the chloride group. There are 3 sulfide groups. Group 2 is divided into 2 groups, 2A, 2B, and we also have group 4. Well, group 2A is the copper group. It consists of copper, cadmium, lead, bismuth, and mercury. All are precipitated as sulfides. Group 2B is the arsenic group, which contains tin, antimony, and arsenic. All, again, will precipitate as sulfide complexes. Group 3, the iron group, is also referred to at times as the hydroxide group. It contains chromium, aluminum, iron, and manganese. These will precipitate as hydroxides and oxides. Group 4 is the zinc group. It is a sulfide group consisting of zinc, manganese, nickel, and cobalt, all of which will precipitate as a sulfide. Group 5 is the calcium group and sometimes referred to as the carbonate group. It contains calcium, strontium, and barium. These all precipitate as carbonates. Group 6 is the magnesium group. The elements in this group do not precipitate, as they stay in solution as ions. Special treatment is used for the separation and identification, as you will learn in the next 2 or 3 presentations. The separation scheme that I am going to introduce you to is qualitative and is based on different chemical principles involving the solubility product concept, acid-base reactions, redox reactions, which involve the reduction and oxidation of species, buffers, and the common ion effect, all of which will be discussed in future presentations within this series. In Part 3, I will be showing you the steps which are commonly used for the qualification analysis and try to explain some of the chemical reactions involved. By doing so, I hope that you will be able to gain some understanding in regards to the logic and principles that make up the procedures that are involved. Please like, subscribe, and share. It's my only reward. I am Rob Boyko, Boyko Mineral Exploration, and I hope to see you in Part 3